So what we'll do is now we will do a small lab in IPv6. You see, I taken two routers and I'm going to assign 1111:1111/128 on the loopback. Likewise, an R2 loopback, I will take 1111:1111/2. Because it is /128, you can use that same 1111, or you say no, let me give 2222. Okay. Everything is okay. Now next is between these two routers. Here, I want to give the complete IP address 2000. Okay, let's make it something interesting. ABCD ::1/64. What does this mean? The first hexadate is ABCD. The last hexadate is 1. The remaining 6 hexadates of values are zeros. So here in this address, I have given both the interface prefix as well as the network prefix. Network prefix in the sense, I mean what? The network ID, the global prefix. The global prefix is what in IPv4 we used to call as network prefix. So ABCD is the network prefix or the global prefix or the global ID, network ID, and that one last number 1 is interface prefix, because out of 128 I have put mask as 64, which means out of 128 first 64 bit only network, the last 64 is still for the interface, the host. So ABCD ::1. On router 2, what I'm going to do, I'm going to give only the network portion, only the global prefix. ABCD ::/64. What I have not said here is I have not given the interface identification. I have not given the host ID. In our old terminology, host ID. So, is it possible? Yes. Host IDs can be dynamically assigned. What? If host ID can be dynamically assigned, then here also don't give the host ID. Will it work? Of course it will work. What if these two routers give the same host portion? What if these two routers give the last number ::1? Won't that conflict? See, it won't give like that. ABCD ::/64 is the network portion, is the global prefix network portion. The interface portion is not given by us. I told you an interface portion can be given by the router and it will be unique. It won't conflict in any manner. See, if I ask you to choose a color, there are chances that two of you will give a same color that you like. If anyone asks me what color you like, I say I white. I like white. White. Always white. Anything you buy, white only you buy. I say white. There may be another participant here in this class who also likes white. So see, there is a conflict. We both say the same color. But when you ask these routers to give interface portion, it will never give a conflicting address because they are going to use the MAC address which is there on that interface, which is already unique. See, our today's focus is on this one. How a MAC address becomes interface portion of the interface ID of the IPv6 network. Why do we have this question? Both are hexadecimal. MAC address is also hexa. IPv6 is also hexa. What's wrong in taking a MAC address and making it as an interface ID? That may be your thought. But my thought is different. Or sometimes your thought and my thought may be this. What? MAC address, as far my knowledge, it is 48-bit. Whereas the interface portion of IPv6 address is how many bits, Sheikh?
So into 64 bits, sir.
64-bit. Then how can a MAC address, which is only 48-bit, can be used as the interface portion of the IPv6 address? This may be our question. How? That's what we are going to see. So far I have showed you the two ways. There is also a third way, which I'll show you after we learn this one. So the first method is you give the complete IPv6 address like this. The second method is like this. You are going to tell the router, I'm not ready to give you the interface portion. You can take the unique identifier. What is the unique identifier of a device, of an interface? MAC address. But MAC address is how many bit? 48-bit. So you need to do what? Extend it. EUI, extended MAC address, extended unique identifier. So if you tell the router, I need your favor. You just take the MAC address, extend it to 64-bit, and use it as the interface ID. So router is going to do it for you. So when you take a MAC address of an interface on the router, no two routers can have same address, not possible, because MAC address is already unique. Okay, so let us see these things. Okay, I'm on R2. Let me start from R2. Interface loopback 0. See, I have not said any IPv6 address so far. When I type do show IPv6 interface brief, you can see the loopback interface is created, but no assigned IP address. No address is assigned. What is the command? Show IPv6 interface brief. Wherever we used to put IP, I need to replace with IPv6. This is not something new command for you. If you want to check the routing table, show IP route we used to type. Now we need to type show IPv6 route. Yeah, and if you want to check the interfaces, show IPv6. Now, why did I bring you here? I want you to confirm that there is no address. And now, interface loopback 0 IPv6 address 2222:2222/128. Now, if you go back and check the loopback 0 interface, you will see this address along with this. You will find another address also, which is called link local address. I am not going to talk on that topic today. But you should know in this class that when you configure a global unicast address, what is global unicast address? The address that you use for communication. When you configure a global unicast address, a link local address will be dynamically generated and assigned. That is what I want to show you. All right, a link local address is going to be dynamically generated and assigned. And it is already assigned. Let me show you that. Show IPv6 interface brief, you see. I gave only this address and you saw me typing this address. Did I type any address starting with FE80? No. This is called link local address. Though I am not going to talk about the purpose of this link local address, I just want to refer this with the EUI. We just learned, someone has not muted your mic, please mute your mic. We learned that EUI is taking the MAC address and extending it. Actually, you know, for the link local, whether you say EUI or not, that is how link local addresses are built. Link local address takes the MAC address. For the link local address, the routers take the MAC address and they extend it into 64-bit. Now, what I want to say here is, even though loopback interface don't have a MAC address, see, loopback interface is a virtual interface that you created. Do you have any MAC address for this? Then from which MAC address? If EY64, if EY is taking MAC address, which MAC address the loopback interface would have taken? it would have taken the physical interface MAC address and using it. It is okay. How it is okay. We'll talk about those how and all later. Now, what I'm coming to say, the answer is the loopback interface will take the MAC address of the physical interface, extend it from 48-bit to 64-bit, and use it as the interface portion. Okay, now I would like to go to this interface G3/0. Interface G3/0, no shit, IPv6 address ABCD:/64, meaning I'm only giving the network portion. Remaining interface portion, you need to EUI64, meaning take the MAC address, which is a unique identifier, extend it to 64-bit and use it. Hit enter. Now you will see that wonder. I configured only half the address, but you will see two addresses on this interface. One is the completed version of this address. Other one is the link local address. Show IPv6 interface brief. You see here, ABCD::: is what we gave. It has taken the MAC address and extended it. I was telling you, even the link local address will use the same MAC address and it will do the extension always. That is why it is matching. Now let us see the MAC address of this interface. Notepad first. I'll paste this portion. I told you this portion is 64-bit and made up of MAC address. MAC address is only 48-bit. To prove that, I would like to copy the MAC address of this interface now. Show interface, this interface. And the MAC address will be in the bracket on the top. This is the MAC address. Now I would like to paste this MAC address here. You see, 56, I said 54, here also 54. This leading 0 has got no value, so it is removed. Next, here also you have 52, here also you have 52. Okay, let me keep the 0 which I deleted. Now what I want to show, before I say these things, I want to show you that there is something here which is not seen in the MAC address. See, I can see the 6 here, I can see the 52 here. Yes, exactly right in the middle of the MAC address, right in the middle of the MAC address. Always, in every case, don't say only in this router it has added FFFE. No. In every interface, it is going to add the same value right in the middle of the MAC address, FFFE. This FFFE is, what is the size of FFFE? 16-bit. What is the size of a MAC address? 48-bit. What is the size of the interface ID of a IPv6 address? 64-bit. Then what is the difference? 16-bit. That is what this 16-bit. In order to extend the 48-bit into 64-bit, it has added the 16-bit value. And always it is FFFE added in order to extend. Now you can remove this to leading 0 in IPv6. That's how we always write. We don't put leading zeros, which we learned in the previous class. And this leading 0 is also not needed. But you cannot change this 0. It is not a leading 0. It is middle 0. It is middle 0. Now, all these things are matching. You are very happy. Wow, wow. But you are not happy with this A. You are happy with the C also. Okay, yeah, everything is matching, but that one thing, I don't know why. It is A. Why it is A? The answer is, as per the standard, they have made seventh bit from the left to be inverted. Seventh bit from the left, when you invert, this is how it will become. But before I show you by inverting it, I want to tell you why this standard is first place. Why did they did this as a standard way of extending a MAC address? When you extend the MAC address, simply taking MAC address and extending with FFFE, they found that the extended version of the interface IDs matches with some old standard of reservation MAC addresses given for the virtual machines. Before IPv6, for virtualization, they reserved some set of range of MAC addresses. They found that if you don't inverse the seventh bit from the left, if you don't change that 8 into A, if you leave it as 8, it may work fine on the physical environment, but in the virtual environment, sometime, if the virtual environment also runs IPv6, then there will be a conflict with those addresses. To avoid such conflicts, they came with this solution of inverting the seventh bit and made that as a standard. See, all these things you are not going to do. As per the standard, operating system is doing it, we are learning it. Okay, operating system is what by the end of the day going to do it. I'm just answering how it has become A. I'll show you how it has become A. First, let us write this one in binary. Seventh bit is inverted. First of all, C. How do you write C in binary? C means what? 12. 12, you write 1, 1, 0, 0. This is 12. 8 plus 4. And then 8, 1, 0, 0, 0. And then 0, 0, 0, 0, 0. Why I type 4 times? Because I'm converting the hexa into binary. 2. Sorry about this. 2. 0, 0, 1, 0. This is what the 16 bit is what written here in an hexa format. Seventh bit from the left. 1, 2, 3, 4, 5, 6, 7, 8. Now I want to invert the seventh bit. This is the seventh bit. I invert it. If it is 0, I put 1. If it is 1, I put 0. Now, you see, every 4 bit is 1 hexa bit. Is there any change in this? No. So same 2. Is there any change in this? No. Same 0. But you see this one? What is this? 8 plus what is this? 2. 8 plus 2 is 10. 10 in hexa, how do you write? A. means 10 in hexa. Did you understand how you got this? See, you did not do anything for this. It is done dynamically as per the standard. All right. So I have given an explanation how this MAC address is taken and extended. For extending, it is adding FFFE right in the middle of the MAC address. Not only that, it also inverts the 7th bit from the left. All right, now we got the IP addresses. Check the routing table, show IPv6 route. You will see the routes in the routing table. It says there is one connected loopback connection with this address 128. There is another physical network connection with this is the network, but the IP address on the link is dynamically generated like this. All right, now let us move on to the second, first router. On the first router, interface loopback 0, IPv6 address 1111:1111/128. Interface G3/0, no shit, IPv6 address ABCD:1/64. You see, I have not even hit enter, okay? I have not even hit enter. I am copying this to second router and I'm saying ping. It won't ping if I didn't hit enter, but as soon as I hit enter, you see, I'm pinging. The ping happens. How? I just hit enter there and I'm able to ping. In IPv4, this is not possible. You hit enter and you ping one packet dot, another packet dot, maybe the third packet exclamatory mark, exclamatory mark. Why the dot dot? Because they are trying to do the inventory. They are trying to do neighbor discovery by using ARP. I told you in IPv6 there is no ARP. So they use the link local address and discover the neighbor before you hit enter, before you ping. The neighbor discovery got over already. The true host to host connectivity you will find in IPv6. Whereas in IPv4, only when you try communicating, it will establish the host to host connectivity. That's why in IPv4, whenever you ping for the first time, you lose few packets. In IPv6, you will never see. You will see the readiness of the network. Let's ping now.
So can we see the this neighbor
Yeah, that
discovery
is what
table
our
on the
tomorrow's
host?
topic. But still, because you asked, I'll show you. Show IPv6 neighbor discovery ND neighbor. Okay, this is what. See, it has already learned the MAC address of the other router, which is on the left. Okay, so we will go deep into this one, how discovery happens and all those stuff. And it uses multi-guest address. It's a long story. In our next class, I keep that separate class. So for your question, can we see the neighbor discovery? Yeah, this is what it shows for this global unicast address ABCD:1. This is the MAC address. And the interface via which it is learned is G3/0. Now, when I try to ping the loopback, I'm not pinging because there is no route in the routing table. Show IPv6 route. Is there any route for 1111? No. What I can do is I can write a default route. Listen, IPv6 route :/0. Send it to ABCD:1. This is what default route means. Any network, any subnet must. Now if I ping, I'll get the reply. I think there is some problem. I was pinging the wrong address. I don't have one, I have 11111, okay? Now let me ping 1111. You see, very first packet is flying like that. And let's check the routing table. You see, S default route. You will not see star here. In IPv4, for default routes, you will have a star. Here we don't have any star. So in this class, what we learned is the two different ways of assigning IPv6 address. There is another way called auto address configuration, which I would like to keep it after we learn the neighbor discovery process, because they are all using multicast ICMP version 6. I would like to teach as a separate topic. Today we stop